in this example, we're going to be working on problem number 38. And basically what's going on here is a study by Consumer Reports showed that 64% of supermarket shoppers believe supermarket brands to be as good as national brand names. So to investigate whether this result applies to its own product, the manufacturer of a national brand ketchup, and let's call it Heinz or whatever, asked a sample shopper whether they believe that supermarket ketchup was as good as Heinz. All right, so let's do Heinz ketchup. Fair enough. And so we've got a certain amount of givens, and then I've got a form here that will take us through the process of evaluating whether or not the sample that was generated of 100 shoppers proves that the brand is the same as the national average of 64%. So what we start out by doing is, let's take it from the top, and what are our givens, right? Okay. We know that this is going to be a proportion analysis, so the P is equal to 0.64. Now we also know that, what else do we know here? We know as good as, so that you really don't get much of a direction there. So we're probably going to do a two-tail analysis. And what else do we know? Okay, so the national brand 64%. Now you take this sample, this P bar, is equal to, and we're going to declare that as 52.52 as the ratio. You just take 52 divided by 100. So this is 0.52. So let me see if there's anything else we need to consider here. No, I think we're good. We're going to do this at 95% most likely. And we're going to make conclusions and recommendations accordingly. So given this, what is an appropriate problem statement? Well, this is just a Heinz. I'm going to go Heinz ketchup. Just wants to know, H-E-I-N-Z, Heinz ketchup, just wants to understand what is their perception in the marketplace compared to store brands, such as a Kroger or National or Aldi or someplace like that. All right, comparative. And why is this important? Because with brand, a manufacturer is able to charge a higher price, generally. And if the brand itself doesn't command a higher price than the generic, then that could be an issue from a profitability standpoint, which is always an issue in business and many, many other situations. So now we ask ourselves, what is the most appropriate null hypothesis? So we know that, here's our question, does the brand matter, is basically what we're asking here. Does brand matter? And so we're going to start out with a null and an alternate, and I'm going to declare a two-tail here because you're not really getting much of a direction from the scenario that was given. And so I'm going to declare HO. Okay, HO is that P is equal to 0.64. Fair enough. And the alternate is just the opposite, HA, where P, the proportion, for the sample of 0.52, does not equal 0.64. And so, as mentioned, we're going to do a two-tail proportion hypothesis test. And we're going to do this on a scale of Z. We're going to be conducting a Z testing. All right, and with a proportion, you'd always basically you just always go with the z-test. At what confidence level would you conduct the hypothesis test? When in doubt, we're going to conduct this at 95% confidence level. You could also identify that as sig.05, p less than 0.05. So the key here is that if you get a p-value that's less than 0.05 for the test statistic, the z-test statistic, you would reject the null, which in this case is it's equal to 0.64, and then you accept the alternate. So what are the critical values for the type of hypothesis test selected? Pretty straightforward. We did a two-tail, so I'm going to go to my z-chart, and the first thing I'm going to do is, since I'm on a two-tail, I'm going to split the alpha. Well, that's another way you could write that. Alpha is equal to 0.05. But on a two-tail, remember, you got to divide that alpha by 2, or 0.025. And we come in here, we do a reverse lookup. I'm going to use the positive z-table to create the critical values for this testing model. And so 1 minus 0.025 is 0.975. So you come over here and you do a lookup. Okay, 0.025, 1 minus 0.025 is 0.975. So now there's a critical value, okay, of z sub alpha over 2 to the positive is equal to, again, 1.96. The negative z sub alpha over 2 is equal to minus 1.96. All that makes sense. So here you have it. I just divided by 2 as we discussed, and I looked up z sub alpha over 2. Now the next question is, what is the test statistic? And for that, I'm going to use my handy-dandy formula. Okay. And this is for a test statistic where there's a target already identified, which in this case is the 0.64 way up here on the givens. So the test statistic is going to be p bar minus p sub 0. This could also be called p sub 0 instead of just p. Okay, divided by the square root of p sub 0 times 1 minus p sub 0 divided by n. And so it really becomes plug and chug. You knew up here that the n was going to be equal to 100. Okay, because that was the sample for n that was given back here. Remember that? 100 choppers. And we're going to take p bar. Okay, sometimes you'll see this as a p hat, but I think the textbook most likely uses either p bar, or it might come out as a p hat. Okay, a p hat, but let's keep using the p bar here at this point. Is equal to 52, is just a plug and chug, minus 0.64, so p bar, 52.64. Okay. And then I'm going to divide by the square root of 0.64, which was our p sub 0 value, times 1 minus 0.64, divided by 100. And if you ran that out, you would get a value of minus 2.5. So this calculated value here becomes your test value to run against a model that you'll create using z sub alpha over 2 at those critical values. Okay. So everything's lined up. All we really have to do at this point is create our sketch. you see normal distribution, you know to immediately go to something that looks like this. They don't take off for artistic ability or lack thereof in the exam. Okay. And essentially what you're doing is you're just asking, is this is the value for 0, because if you took p minus p sub 0 and it's equal to 0, then those values are the same on a sampling and on an inferential basis to the overall population. Remember, we divided by 2 to get 0.025, so under this area of the curve is 0.025, and under this area of the curve is 0.025. And here, everything in here is 0.95. Okay. This is 0.95. And so that 0.95 creates your do not reject zone for HO. Now, out here, in these two areas out here, where the error can occur on your HO, you would have, this is the reject. Okay. The reject HO. Same way over here, this was where you would reject HO. So your test model is set. You've got two rejection zones. You've got a do not reject zone. And now what you do is you take your z sub alpha over 2 that you calculated or you determined back here from your z chart. And so you know this is z sub alpha over 2 is equal to 1.96 and minus z sub alpha over 2. That is a negative z sub alpha over 2 is equal to minus 1.96. The stage or the model is set. Your test statistic is minus 2.5. So you simply come in here and you take, your finger or whatever and your pencil, and you just say, okay, where does minus 2.5, our test statistic, where does that fall? Okay, and you can see that it's going to fall right beyond, or well beyond actually, minus 1.96, and so you would indeed reject HO. Now, if that test statistic had been calculated and it fell in here on the test model, you would accept HO, and the numbers are actually the same. But in this situation, you're seeing that the national average is not exactly what Heinz is hitting here when they're at a 52% as far as equality of brand versus a generic. Okay, so that's pretty much the way you analyze that. Now, the other thing we can do here is that, so that's the critical value method. Okay, so this is the critical value method, and you'll be asked to do both on the exam most likely. Okay, now the other thing you can do is you can get an actual probability or a p-value to compare against. Remember, p less than 0.05, not the proportion, but this is the same as sig.05. Sig.05, right? Not to be confused with these p-values up here that were the proportions. This is the actual probability that you're going to be wrong at a 95% confidence level. But keep in mind, again, you need to divide this by 2. So when you go in and you look up minus 0.25, all right, minus 0.25, 0.0062, 0.0062, correct? However, when I got that one more time, as I went to, because it was a minus 2.5, 0.0062. However, because it's a two-tail, I need to multiply the probability that I found for a two-tail value. And so in this case, I'd get a 0.0155 or 54. No, it'd be, oh, hold on. 2 times 0.0062. Just recheck that number one more time. 0.0062. 2 times 0.0062 would actually be 0.0124. Correct? Now, here again, you would, this is P less than 0.05. This is less than 0.05. 0.024 is clearly less than 0.025 or 0.05. Okay, so here you would once again, clearly you would be rejecting the null. And indeed, the Heinz ketchup is having a little difficulty here because the national average showed that 64% of supermarket shoppers believe supermarket brands to be as good as national brands. Okay? But when it's compared to Heinz, okay, the generic starts running into problems because, at least in this situation for Heinz ketchup, correct, you're rejecting, which means it's not the same as 64.64. It's actually lower. And so this is coming out favorable for Heinz ketchup. Okay. And as a result, the supermarket brand, you would conclude that the supermarket brand at least compared to Heinz is pretty much more inferior from a quality perspective. More inferior for quality compared to the national brand and the normal target value of 0.64 that we had originally. And this is 0.52. So Heinz is actually doing better. So what's really going on here is that most likely the Heinz brand, as with anything else in marketing, it has to do a lot with the brand awareness and the perceived quality. And in this case, Heinz could probably command a slightly higher price since they're doing a little bit better against the national average, so they could probably command a little bit higher price for Heinz ketchup than for something that was closer to 0.64. And so you're getting some nice profit margins here. Or maybe if your prices are too low, you're still getting that at 0.52. When you come back to your original question, or the original problem, Heinz ketchup comparative, and does brand matter? So clearly, brand matters. More so with Heinz ketchup. That concludes the video.